Welcome to Classes with Atish. Today I'm going to solve one problem in kinematics from Irodov, and this is problem number 1.8. So I will have the problem somewhere up here so you can refer to the question. Take some time to pause the video and see if you can solve it by yourself, okay? But let's look at the problem now. So 1.8, two boats A and B move away from a buoy anchored at the middle of a river. In these problems, the most important thing is to have a clear picture of the problem. So let's do that first. So here's the river, okay, and it says, so there is a buoy which is anchored in the middle of the river, and two boats move away from this, one in the direction of the flow of the river, and the other perpendicular to it. Okay. Alright. Now let's assume the velocity of the river is v0. A velocity of A or B with respect to river, let's assume that as V. V is nu times V0. Okay, so that is a given. Now, so this is A and this is B. So what they are doing is they are going equal distance and then coming back. Okay, we have to find out the ratio of times of motion. So tau A divided by tau B. Okay, let's look at boat A first. Okay, so what should be tau A, the time taken for the journey going this way and coming back this way. So time is distance divided by velocity, right? So if we assume this equal distance that they are going is each is equal to d, so then this will be d divided by, during the motion in the direction of the flow of river, the relative velocity is v, which is A's velocity plus v0. Okay. Now on the return journey, again it will cover the distance d. Okay. But now the velocity is v minus v0 because it's going in the opposite direction to the flow of the river. Okay. So this can be calculated pretty easily. So v square minus v square. Okay. Now let's look at what's happening with boat B. Okay. So when it goes this way, now there is a trick here. For boat B to travel in the perpendicular direction to the velocity, to the flow of the river, its velocity with respect to the river should be at an angle, right? Because when you add these two vectors, if this is v0 and boat B's velocity with respect to water is v, is v, then only what will happen is the resultant vector in this direction, right? So now let's assume then that this angle is theta. Okay, so let's write some equations of motion. Now V0, V cos theta is the component of V in this direction, which is responsible for this travel, right? So let me also write this is onward journey, and then return journey, the case will be a little different but almost similar. So in the return journey, the velocity of the port B should be in this direction, whereas the stream or river velocity is in this direction. So this is V0 and this is V. So the resultant will be in this direction, which is the direction of travel of B. Okay, again it's very obvious that this angle will also be theta because none of these individual velocities changed. Okay, so then V cos theta is responsible for the movement of boat B in this direction. Similarly here also V cos theta is responsible for the movement in this direction. So tau B will be what? Will be T divided by V cos theta, but we are going once and coming back, so it is 2D divided by V cos theta. Okay, now how do I find theta? Very simple. Now boat B is not moving in the direction of the flow of the river, right? So that means V sin theta must be equals to V0. Okay, so from this sin theta is V0 by V, so cos square theta is 1 minus sin square theta, or we can write 1 minus V0 square by V square. So cos theta will be root of that. So tau B, if I go on writing, expand tau B, so it is 2D divided by V cos theta, so that is V root 1 minus V0 square by V square. Okay, now we have both tau A and tau B, so our goal is to find the ratio. So what would be the ratio? Tau A divided by tau B should be 2VD divided by V square minus V0 square divided by tau B is 2D divided by V root 1 minus V0 square by V square. Okay, how 2D we can cancel out. Okay, let's take V square common, so 1 minus V0 by V square. Okay, and this is 1 divided by V root over 1 minus V0 square by V square. This can be written as 1 divided by 1 minus V0 square by V square. Okay, now what is V0 by V? V0 by V is 1 by nu. So we can write this as root 1 minus 1 by nu square, or nu goes in the top, root nu square minus 1. So that is the solution to question 1.8. Cheers.